In this class, we are going to learn how to solve quadratic equation using the completing the square method. We make use of completing the square method when the equation that we are asked to solve is not factorizable. You understand? A typical example is the equation x squared minus 6x minus 4. X squared minus 6x minus 4 equals to 0. This equation is not factorizable because it doesn't have a perfect square. You understand? So in an attempt to solve this equation, we make use of completing the square method or the general formula. But in this class, we're going to be focusing on completing the square method, okay? So let's start. How do we solve this equation using the completing the square method? The first step is that we're going to move the constant term to the other side of the equation, okay? Let me quickly explain to you how to know if an equation is factorizable or if an equation has a perfect square or it doesn't have a perfect square. Okay? If b squared minus 4ac is a perfect squared, then the quadratic equation, if b squared minus 4ac is a perfect square, the quadratic equation has a simple factor. But if it is not a perfect square, that means that the quadratic equation does not have a simple factor. You understand? That is not factorizable. So let us check. B is what? B is negative 6. So I'm going to have negative 6 squared minus 4 multiplied by 1 multiplied by c, which is what? Minus 4. Please, do you understand what how I got this? In our previous class, I've told you that a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. You understand? So b squared, which is negative 6, minus 4 into bracket 1 multiplied by negative 4. You understand? Okay, so I'm going to have 36 minus 4 into bracket minus 4. So 36 plus 16. What's the answer? That is what? 52. You understand? So here you can see that 52 is not a perfect square. You understand? 52 is not a perfect square. So as you can see, the quadratic equation is not a simple, doesn't have a simple factor. So we solve this using the completing the square method. Now, in an attempt to solve this using the completing the square method, the first step is that you have to take the constant term to the right hand side of the equation. You understand? So here I'm going to have x minus 6x equals to 4 because the constant term is what? Negative 4. You understand? So when it crosses the equals to sign, the sign is going to change to positive. You understand? Okay? So the next step is that you have to check the coefficient of x squared. If the coefficient of x squared is not 1, you have to divide the equation by the coefficient of x squared. But because the coefficient of x squared is 1, that is, it is unity, there is no need for dividing, there is no need to divide or to go by the coefficient of x squared. You understand? So the next step is that we have to just find the half of the second term, take the square and add it to both sides of the equation. Okay? The second term in this equation is what? Negative 6. So I'm going to find the half of negative 6. Half of negative 6 is what? Negative 3. So I'm going to square negative 3 and add it to both sides of the equation. You understand? Okay, so I'm going to have x squared minus 6x plus minus 3 squared equals to 4 plus minus 3 squared. Do you understand? Take the half of the second term, square it. The square, sorry, it is not cube. Take the half of the second term, square it, then add it to both sides of the equation. Okay, so now having gotten to this point, the next step is that we are going to rewrite the left hand side of the equation as a perfect squared. Okay, so here I'm going to have x minus 3 squared. This is a perfect square for this for the left hand side of the equation. If you open this bracket, you are still going to have this. Okay, so I rewrite this as a perfect square. So this is it. Okay, anytime you are rewriting the left hand side as a perfect square, you just have to take one value of x, then the half of the square of the second term that you had, take one as well, then square both sides. By the time you expand this bracket, you are still going to have this. Do you understand? Okay, so this will be equals to 4 plus 9. Okay, here I'm going to have x minus 3 equals to, okay, x minus 3 squared now equals to 13, okay? So from this point, we can take the square root of both sides. So I'm going to have x minus 3 is equals to the square root plus or minus 13. You understand? Okay, what is the square root of 13? The square root of 13 is, okay, let's proceed. X minus 3 is equals to plus or minus. The square root of 13 is 3.6056 plus or minus 3.6056. Okay, so here I'm going to have x equals to, if this negative 3 causes the equals to sign to the right hand side of the equation, I'm going to have the negative sign is going to change to positive sign. So I'm going to have 3 plus 3.6056 or 3 minus 3.6056. Okay, so here x will be equals to 6.6056 or now 3 minus 3.6056, that is 0.6056. You can leave it in 3 decimal place, or you can leave your answer like this depending on the options. Okay, so that is the solution to this question. Do you understand? Okay, so this is the value of x that makes the quadratic equation this equals to 0. Okay, so let's proceed to question number 2. Question 2, we are asked to solve for the value of x in the equation x squared plus 8x plus 5 equals to 0. X squared plus 8x plus 5 equals to 0. Okay, so we are still going to use the same step. You understand? Now the first step is that you have to take the constant term to the right hand side of the equation. So here I'm going to have x squared plus 8x is equals to negative 5. Okay, now the next step is that you have to divide all through by the coefficient of x squared if it is not 1. But because it is 1, there is no need to divide. You understand? Let's say we have 2 as the coefficient of x squared. I'm going to divide all this equation by 2. You understand? But because the coefficient of x squared is 1, so there is no need to divide all through by the coefficient of x. You know, coefficient of x squared. Okay. Now let us proceed. Here, so the next step now is that we have to take the half of the second term, then square it. After squaring it, we are going to add it to both sides of the equation. This is the second term. You understand? Half of the second term means I'm going to have half of 8. That is what? 4. So I'm going to square 4. It is this square that I'm going to add to both sides of the equation. So here I'm going to have x squared plus 8x plus 4 squared is equals to minus 5 is equals to minus 5 plus 4 squared. Okay, so I'm going to have, now don't forget what we did when we got here. We will write the left hand side of the equation as a perfect square. Do you understand? So, and I told you that this is what it means. Just take x plus 4 squared. You understand? This is the perfect square of this, equals to minus 5 plus 16. Okay, so x plus 4 squared is equals to minus 5 plus 16. What's the answer? That is 11. Okay, that is 11. Now the next step is to take the square root of both sides. So here I'm going to have the square root of this plus or minus the square root of this. Okay, so this square will cancel this square. Okay, this square root will cancel this square. So I'm going to have x plus 4 is equals to the square root of 11 is what? The square root of 11 is 3.3166. Okay, plus or minus 3.3166. Okay, so x is equals to negative 4 plus 3.3166 or negative 4 negative 3.3166. Do you understand? Now negative 4 plus 3.3166, that will be, let me punch the calculator here. That is negative 0.6834. So x is equals to negative 0.6834, or that is negative 7.3166. You understand? So the value of x that makes the quadratic equation x squared plus 8x plus 5 equals to 0 is x is equals to negative 0.6834 or negative 7.3166. Okay, so that is the solution to that question. So when you come across question that you realize that you cannot factorize it, having taken the having checked, you realize that you cannot factorize it, just make use of completing the square method. And if you understood very much the general formula, you can make use of that as well. You understand? So that is the solution to that question. That will be all for this class. See you in the next class.